chain rule examples. First problem, we're going to find the derivative of tangent of square root of x. The chain rule says we can take the derivative of the outside function times the derivative of the inside. The derivative of tangent of an angle is secant squared of that angle. Notice I kept the square root of x inside the secant squared. That's my outside derivative. Then I have to multiply by the derivative of the inside. The inside is square root of x. That has a derivative of 1/2 x to the negative 1/2. Finally, I'll rewrite that 1/2 x to the negative 1/2 as 1 over 2 root x. I just brought the x to the negative 1/2 to the bottom. And we can also write this answer as a single fraction, secant squared square root of x over 2 root x. In example B, we're going to have to use the chain rule multiple times. I'm going to start by thinking of this function as -2 sine of 4x to the 5th. The outsidemost function is the 5th power. To take the derivative of something with a 5th power, we bring down the 5, that gives me a -10, and then I have sine of 4x to the 4th. Notice the thing inside the parentheses, the inside function is not changing as I'm taking the derivative. Okay, so brought down the 5, 5 minus 1 turned into a 4. Now I have to take the derivative of the inside function. I have a sine of 4x, so I start with the sine. Derivative of sine is cosine. That gives me cosine of 4x. And then finally, we have a 4x inside that sine. Derivative of 4x is 4. I'm going to multiply the 4 times the -10 and just rewrite my final answer. In my last example, we want to find the x-coordinate of each point where the graph of g of x has a horizontal tangent line. A horizontal line has a slope of 0, so we're looking for places where the derivative equals 0. I'm going to start by finding the derivative, and I'm going to have to use the product rule. The first is x squared. The second function, the g, is 2x plus 3 to the third. F prime would be 2x, and g prime, this is where I'm using the chain rule. I brought down the 3, 2x plus 3 squared, and then I have to multiply by the derivative of the inside. The inside is 2x plus 3, so I multiply by 2. Using the product rule, I take f prime times g plus g prime times f. And when I wrote this down, I did multiply the 3 and the 2 together in my g prime. That's where that 6 came from. So f prime times g plus g prime times f. And then I have to set this thing equal to 0 and try to solve. And to solve this equation, I'm going to factor. I notice that both terms have a 2x plus 3 in them. That's going to be part of my greatest common factor. In fact, I can take out a 2x plus 3 squared. We can also take an x out of both terms and a 2 out of both terms. So the GCF would be 2x plus 3 squared. I pull that out front. In the first term, we took out the 2x, and we took out one of those 2x plus 3, we took out 2 of the 2x plus 3's, so we have one of them left over. Second term, we took out both of the 2x plus 3's, those are gone. We pulled a 2 out, so I'm left with a 3. We took one of the x's out of the x squared, I'm left with an x. Finally, I'll combine like terms in those brackets. 2x plus 3x is 5x plus 3. And now I can set each of the factors equal to 0. 2x equals 0 when x is 0. 2x plus 3 equals 0 when x is -3/2. And 5x plus 3 equals 0 when x is -3/5. So those are 3 places where the graph has a horizontal tangent line or a slope of 0.